Alright, so in this STEM problem song walkthrough, we are going to be solving a problem from an old AMC examination, so let's get started. So find the smallest composite number that has no prime factors less than 10. No prime factors that are less than 10. So what this means is if we have a number, let's say n, so what this is basically saying is we can't have any prime factors less than 10. So when you take the prime factorization of n, we can't have 2, we can't have 3. These are not possible. It has to be like 11 or 12 or 10, because 10 is 10. It's not less than 10. So let's just get started. So I'm going to erase all of this, and we're going to start fresh. So, getting started, no prime factors less than 10. So here we are going to build the number using the factors. We're going to build a number by using factors instead of just finding this number like regularly. So when we build our number, we start from 10. But if you notice, we have a pattern. We need to eliminate some numbers first, because we can't obviously try all of these numbers up to the number. So let's start with 2. It can't be a multiple of 2, because 2 is less than 10. Can't be a multiple of 3. 3 is less than 10. Can't be a multiple of 4, because 4 is a multiple of 2. Can't be a multiple of 5. 5 is less than 10. Can't be a multiple of 6. 6 is a multiple of 2. It can't be a multiple of 7. 7 is less than 10. Cannot be a multiple of 8. 8 is a multiple of 2, and it's less than 10. Can't be because it's a multiple of 3, and it's less than 10. And 10 can't be because it's a multiple of 2. But 11. 11 is not a multiple of 2, 3, 4, 5, 6, 7, 8, 9, or 10. It's a prime number. So let's start with 11. Let's take 11. Now we need to build our second factor. We need to come up with a second factor in order to build this number. Now, if we're going smallest, we have to go to 11. So 10, 11. The only other number I can think of, it cannot be 10. It can't be 9. Can't be 8, 7, 6, 5, 4, 3, 2, 1. It can only be the smallest. We know it can't be 12. It can be 13. But 13 is larger than 11. And 11 is another possible case. And 11 is the smallest of these possible cases. Essentially what we're doing is we first attempted to use range, but now we use a different strategy, and this is building our number using prime factors. And this is just 11 squared, which is 121. Now we think it's 121. Let's take the prime factorization of 121. Well, 11 times 11 is 121. So obviously our number should be 121. But before we make a box around 121, finalize our answer, we need to make sure that this is the smallest number. So let's go back and review our work. We know it can't be 2, 3, 4, 5. It can't be anything from 2 to 10. And it can't be any of the multiples of numbers from 2 to 10. Right? So essentially, every number is a multiple of 1. So we're not including 1 right now. But we can't break down 11 and 11, So when it comes to prime factorization, we can't break anything. Once it's prime, we can't break it down any further. Since if it's prime, the only product is 1 and itself that make that number. So if we're going to get the smallest, both of these prime factors need to be numbers that are prime, or that are not. Both numbers need to be, it can't be a multiple of 2, can't be a multiple of 3. I'm going to actually list down everything it can't be. It can't be a multiple of any of these numbers. It just can't. It can't be a multiple of any of these numbers. But we go to 11. And 11 is a number that we can use for one of the prime factors. Now for the second prime factor, it's the same exact thing. It can't be a multiple of any of these, so we just pick 11, which is the smallest number here that is 1. 11 is greater than 10, right? So if n is 11, 11 is greater than 10, so that already works. It's not a multiple of 2, 3, 4, 5, 6, 7, 8, 9, or 10. And it's the smallest number that is not a multiple of 2, 3, 4, 5, 6, 7, 8, 9, or 10. Right? So, and while 11 is not the smallest prime, it's the smallest prime that's on a multiple of 2, 3, 4, 5, 6, 7, 8, 9, 10, or 10, and it's smallest prime it's the smallest prime that's greater than 10, that's not less than 10. So we know that this is going to be 121, and we know that 121 is the smallest composite number that has no prime factors less than 10. So basically, as a recap, we built our number by just eliminating anything that's not true. If you were to do this more quickly, you would just realize this. You wouldn't have to write everything out. You would just realize it's 11 is the first prime factor, and the second prime factor is going to be the same thing, exact step that you took before. So it's just 121 is our answer. Hopefully this video is helpful, and yeah.